So hello and welcome to today's MTD podcast. I'm Paul Jones, the Managing Director and founder of MTDCNC.com, and today I have the pleasure of being at a company called Printing Portal. I'm with James Hawkins, who is the owner of this business, a company that was founded a few years ago, and as it suggests in the name, is a specialist in 3D printing. James, welcome to today's podcast. Firstly, be good to get a little bit about your background and your history, and what sort of took you into starting this company.
Sure, thanks, Paul. So, no one would connect me, I think, with 3D printing maybe 8 years ago. I was in a bank working on a fairly bland product, should I say, in the money market fund industry. Lovely guys, lovely place, but for me, I needed something a little bit more tangible. And when I had a friend of mine who was it still is an industrial designer, we chewed the fat for many hours about 3D printing and its possibilities, its capabilities. Of course, there was a bit of hype back then about 3D printing. It was in the press quite a lot, and I rolled with it. I did a bit of research and figured actually this is a technology that I think can really change the way that we get parts made.
And that's what's going to be great to tune into on this podcast. We're going to find out about your company, the types of parts that you're making, but of course what you've learned along this journey as well, the technology that you've invested in and why. And I think I'd probably start there, because for a company like yourself, specialists in 3D printing, you need pretty specialist equipment. So what did you procure?
We do. We began our journey on SLA machines, so cheap desktop machines. And although they gave us a nice surface finish, they were quite brittle and you couldn't really use them in a production setting.
So for those that don't know, what would SLA mean? What's the delivery of the finished product come from?
So SLA is a process where a laser cures a photopolymer in a vat. So it's a photopolymer liquid resin, and the laser will cure it into a position, and then each layer is either peeled off or and then the build platform is lowered into and ready for the next layer. Now, it's great for, as I said, maybe mold making. So we'd use print a positive part, finish it off, make a silicone mold, which was great for pouring in polyurethane of different materials with different characteristics. But that's quite a long process and manually intensive.
Is it quite a hobbyist technology as well?
It is, yeah. You'd say it is and it isn't. I mean, for the dental industry, it's massive, and there are other industries out there that use that technology.
Pretty affordable, lower cost.
It can be, but there are larger machines, of course. There are larger SLA machines which do the same job, but with better material sets, to be honest with you. But for us, it was a great starting point. But in order to really get into that production and start, hammering out large parts, in a small period of time, we needed a different technology, and that's where we came to HP's multi-jet fusion.
Well, let's explore that then, because without the want to try and give you more competition by people going out there buying these multi-jet fusions, which I'm sure in fact wouldn't be a problem to you because you've got that entrepreneurial flair anyway to succeed. But tell us what that technology is about and what the differences are.
Well, I guess I'll talk to your first point in the sense that I wouldn't be worried, because it is quite an investment. It's not just on the capital side, but on the educational side. You need a lot of CAD skills and other ancillary machines to really get the best out of the MGF machines. Not saying that as a standalone product you can get some good parts of it, but there is a strong need for the service bureau industry in 3D printing. I think to begin with, they're great for helping people understand the 3D printing process in its entirety. So people who are probably entering or trying to think about entering into the 3D printing market or using 3D printing products, it's best for them to typically go to service bureaus first, because we're the guys that will give them all the information and say, right, well, this is the best technology for you, this is the best material for you, this is the best finish for you. And then beyond that, once they've got that, education, they'll probably look at buying their own machines, no doubt, depending on the volume that they're looking at.
But that MJF technology, is it geared around the application? What does that specific technology give you better results with? How does it work?
So, so how it works. So, multi-jet fusion being different from SLS, which I think is probably its closest comparable. They are both powder-based materials. They differ in the fact that multi-jet fusion uses a lot of HP's proprietary knowledge on material jetting. So they have jets which allow you to deposit small amounts of fusing agents in a specific location. Compare that to SLS, which uses a laser to melt parts into position. For me, I prefer the MJF solution because it was actually very quick. We can provide full builds in 16 hours, no matter what. No matter how dense the parts are, how many parts you have in a build. If you have a full build, it's going to be around 16 hours. SLS, if you have lots of small parts, you've got a laser that has to follow those patterns on each layer, which will add up in your time. So there's a difference in that aspect.
What about the quality of the component though that comes off as well? Is there any way that differs?
I think they're both good quality, to be honest with you, on both the SLS, this Jeff. So for me, the MJF is supposedly more isotropic. So in that sense, you have strength throughout the part and the X, Y, and Z that maybe you don't have so much in the Z value, especially compared to an FDM part. We know this. We've printed lots of parts now, and the MJF parts are extremely strong in most orientations.
And what the technology allows you to do here is to continually run your HP machines, doesn't it? You can run them 24 hours a day, which you've recently been doing.
It does, yeah. So sorry to interrupt, but we had a particular project which now enabled us, or required us, I should say, to print 7 days a week, 24/7. And with our particular setup, where we have build units, and I guess that's a different comparable with the SLS, is that these build units actually go out of the machine into a specially designed post-processing machine, which is really easy for us to use and swap out. So what that enabled us to do when we had a particularly busy patch at the end of last year, start of this year, was to extract a build unit at 6 a.m., run a build that had been prepped and ready to go, build units for the day. When that build unit was finished, we'd extract it by 7 p.m. and then get the next build going. So it was a continuous cycle.
I mean, a couple of the things that we've learned in recent times about 3D printing, some of the barriers to entry have been things like the cooling off of parts, the cleaning of components, but you've eliminated some of those issues with your setup, haven't you, as well, with Matsuura and HP?
That's right. So, I mean, we were very fortunate for a long period of time with our supplier, Matsuura. They helped us get over a bit of a hurdle with the post-processing. But during that time, we realized that there needed to be an investment to get this in-house because we were losing days in our lead times from sending parts off to be post-processed. So it wasn't an ideal solution for us. We invested in the Dimension suite of products, which are 3 machines which allow us to depowder our parts, blast them originally. Then we have the capability to dye them in-house, and if customers would like, we can also polish them with the Polyshot S. So what this really does is get us to a position whereby we're as close as we possibly can be to injection molding before we go on to vapor fusing, which is the sort of, in my mind, is the last leg in the post-processing process, I should say, a bit of a tongue twister, which would seal parts and allow them to be used in aerospace settings and be more, let's say, food friendly.
Because that's the hurdle to overcome, isn't it? Once you've able to supply into those sectors, the game changes completely.
It is. I mean, I think you've always got to. Whenever I make an investment, it's always with the customers in mind. You know, what is it they want? So we know that 80% of our customers are having parts dyed. So to have a proper solution there is really critical for our operations. To have that in house is the best solution going forward. So if we were to if our future investment, it will be on the lines of vapor fusing.
And what would that vapor fusing do then?
So as you sort of touched on just a second ago, it allows us to go into markets which we're currently, I would say, not quite ready to go into. We do parts for them, but if your customer is operating in a clean room, they can't have any powder on their parts whatsoever. With a vapor fusing technology, what you're doing is you're effectively sealing your parts so that there's no powder possible to come off into their clean room, which for those guys is pretty mission critical.
And so if you looked at it, and just to try to put a number on it, if there was 100 products to be made around the world at the moment, 4 or 5 can be 3D printed and say 95 can't because of the reasons we touched on. By having these technologies advancing like they are, in a few years' time, do you think that, that ratio might be up to 50%, 50 out of 100 components can be made because, they can now fly on aircraft, they can now go into the food industry, they can be used in conjunction with medical products? Is this really where your entrepreneurial flair is looking to grow this company?
Absolutely. I think, it is the end game. I mean, for 3D printing, I think it's pretty much shaken off the prototyping image it had for a long time. It's getting towards that, in most people's mind's eye, a production grade technology. But there are certain industries that still require that extra little bit to get there. But there are, I mean, you mentioned aerospace. There are 3D printed parts in planes right now. It's already begun. People are probably unaware of the fact that 3D printing has entered these markets, but they have done so, and they'll continue to do so. But
the stringent regulations to overcome, but again, these are being done at the moment, aren't they? These regulations, some of these the parts, the integrities, the accuracies that are needed. These machines are delivering these, James. I wanted to just ask you another question, which is quite interesting to me, because you mentioned it about production. Where's the split now with the technology that you've got from the volumes of where you would have gone to an injection molding machine previously to where you don't need to at the moment? Thousands off, hundreds of thousands off. What's the?
Yeah, I guess so. I mean, it depends.
Where's the value? Where's the best? When does the return become better from an injection molding machine compared to a 3D printer?
Very hard to say unless you gave me a part in my hands to look at. But I think one of our customers, you could say, is on the cusp of saying, well, they'd tool up and go injection molding, but they haven't done so because they're very happy with the level of service. They can get parts on order, so it's a simple phone call sometimes saying, hey, can we just get another 40 of these brackets? So
it's the agility it gives your business, isn't it?
The agility, the flexibility. We have other customers who have to make very small design changes on iterations, perhaps. So for them, it's you would never tool up. So you're getting into volumes now. I mean, as I mentioned, we did about nearly 50,000 clips during the March lockdown for the medical industry. Now, people would never in a million years think that you could do 50,000 clips in 5 days prior to, I think, to 10, 20 years ago. So the industry has moved forward. I think throughput is certainly a big requirement to catch up and take on more parts that would be injection molded. Obviously, the other thing is cost. People do look at cost, but I think costs are coming down continuously. They have been for the last 10 years. We know that people always sometimes get surprised at our our prices and think, actually, well, with these prices, why would we tool up?
And I think you've got an advantage because you haven't, as you said at the start of this, got a history or education in machining or general engineering, which often clouds your judgment when you look at 3D printing, because 3D printing is all about creating a part from scratch and doing it differently, isn't it? There's no restriction on design.
It is, and you say that it's sometimes because we do a lot of 3D scanning and reverse engineering. So obviously we're coming into contact with heritage parts which have been designed a specific way for CNC machining or casting, had to come out of a pattern of some sort. So I do run into it, but even now we actually have a process with our customers where we say, look, we think this design change may improve. Well, it will improve not only the part, but it'll improve the cost of your part because we'll be able to fit more of them in the machine.
Could improve the performance of the product, couldn't it?
Exactly.
The weight, all of these factors which before couldn't be looked at.
Exactly, and it's. I mean, even for us, when we're entering, if someone from a different sector comes in to chat with us, we have to think about it and go, yeah, well, actually, it would make more sense doing it this way around. We use that experience to then help all our customers to maximise the efficiency of 3D printing.
Is there a future at Printing Portal for metallics?
Certainly, yeah. So our roadmap will include 3D printing in metal in the coming years. I think for the polymer side, we're really happy with our product offering. As I mentioned, we would like to get that final finish on the parts. And increase our throughput. Still, we're actually the only company in the UK that has multi MJF machines as a service bureau. We're not stopped there. We want to continue to add to that throughput. But yes, metal will be on the project horizon.
And it's been a pleasure being here today. I've got one final question for you: engineering or banking, which is more fun?
Engineering. Yeah, I love the days in banking. I like the people. There's some really nice people in the city there, but just the variety of things that I'd get up to here at Printing Portal and some of the unique challenges that come our way. It's engineering hands down.
Brilliant. I wish you all the success for the future. Look forward to coming back as well.
Yeah, you're welcome.
Thank you very much, James. So that's it for today's MTD podcast, a real education in 3D printing and what the technology is capable of these days. Keep tuned to our channels for more podcasts. That's it from me today here at Printing Portal.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.